Hey everyone, I'm Austin and Gotti.
My name is Damien.
My name is Dede, and today we are going to present you guys the spot speed study. As an introduction, we came up with the location Fairground Street Southeast. That was our location, as you all guys know. Traffic engineer and transport planner need information about road traffic to be able to develop solution for efficient and sustainable transport system. As a definition of a speed is one of the basic parameter used for describing the characteristic of traffic flow and is an important transportation parameter because it relates to safety, travel time, quality of travel in terms of traffic density on a road segment congestion. And one of the main things that we also talked about was the spot speed study, which is the evaluation of current road traffic congestion. And the purpose of that is that spot speed study is to estimate the distribution of speed of vehicle in a stream of traffic at a particular location. And the speed study just play a huge role in the level of service of road and highway facility in terms of travel speed and time. And I'm going to hand the result over to Austin.
We get three results based on our collecting our data. We get speed, frequency, and cumulative frequency. Spaceman speed, which is our distance, is divided by travel time. Frequency, which is calculated based on the number of carbs observed multiplied by 100. Cumulative frequency is the total percent of observed cars in a particular speed group. So as you can see, based on the graph, the peak hour has a wider range of speeds, while our non-peak hour range is less due to the less traffic flow. Based on our results, we were able to calculate all three of these. Our posted speed limit, which was 35 miles per hour. Our peak hour, which was 11:30 a.m., was 85% percentile, was 42 miles per hour. And our exceeding speed limit was 35%. Our non-peak hour was at 7, which our 85 percentile was 39 miles per hour, and our exceeding speed limit was 38%.
We had to try multiple locations before setting up our speed trap, and because our posted speed limit was 35 miles an hour, we needed a section greater than 176 feet for the minimum trap length. So we picked a section out on Fairground Street across from the Cobb County Civic Center. In figure 1, you're going to see our tripod that we had set up aimed at Fairground Street. And figure 2, you can see our 2 checkpoints that we used to set up the speed trap. Here are closer looks at both of those. They're both very prominent and easy to use for checkpoints. We did have a couple sources of error because we were at such a sharp angle. Our line of sight was off from the sign. And so as you can see from the orange, that's where it looks at from above, where the signs would normally be. The yellow shows our line of sight, and the red line shows the distance that the vehicle actually traveled, which is 310 feet. We also use hand timing, and so there's always a human element of error, and so the times might have been a little bit off. We also experienced cross traffic. We had southbound traffic going in front of the northbound traffic, and so sometimes it obstructed the view of the traffic that we were trying to look at. In conclusion, spot speed studies are used to determine vehicle speed percentiles and the speed distribution of traffic streams at specific locations. It can be affected by various circumstances, such as the cross traffic and also the types of camera angles you use. We have, however, tabulated all the data from the experiment, and we're able to calculate the speed, the frequency, and the cumulative frequency. Again, the posted speed limit was 35. We were seeing peak hour traffic going at 42 miles an hour and non-peak at 39 miles an hour. So in both cases, a third of the vehicles were speeding. Some recommendations would be to decrease the lateral clearance of roadway to cause drivers to be more cautious, and also to implement speed controller signs that promote slower driver speeds. And that concludes our presentation.